Hey everybody, this is Larry. This is me going with Q4 of the Bi-Weekly Contest 110. Minimum time to make a raise sum at most X. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. This video is like 2 hours long or something. But don't be worried. I like to be fully disclosed. So it's just me struggling for about an hour and a half. I think if you want to skip ahead near the end, I basically tried a couple of things during the contest, a bunch of greedy type things that, in retrospect, looking at the solution, it's close, but not quite. I didn't solve it during the contest. I kind of looked at one solution and trying to see if I could prove from that solution, and I was able to do it. And this is one of those problems that, to be honest and to be frank, it's really hard, right? So don't feel that bad, but also that. I think right now I understand it enough to kind of explain it. But to be frank, I don't know if I could, like, if you give me a very similar problem, and I have to look at it, I might not be able to get it still. Like, I think I need more practice with some of the ideas. And the hardest part about this problem is that it takes two or three different core tricky ideas and needing them to put together. A couple of them are okay by itself, and the ideas are fundamental, or like, I wouldn't say basic as in it's easy, but like things that a lot of people have the ability and capability, or they already learned it already, right? It's just about putting them together. So yeah. And again, most of this video is not explanation, so like just skip ahead if you want to watch the end when you could see like how I kind of learn from it, and there's a little bit of a proof, which we'll do it again here anyway. All right, so I'm gonna go over my thought process with this one. It's not, like I said, I didn't solve it, and I don't know that this would lead me to the answer, but it should be at least, let me know if it's a way to kind of understand the solution. Even, usually in these videos, I try to also not just go over the solution, because that's, knowing the solution and memorizing it is not useful. Or at least especially when you get to the harder problems like this one. But it is a step, so let's think about this together, right? Okay. So the first observation that you can make is that for every let's construct something like this for now. Right? For every index, you never want to pick it more than once. Why, right? Let's say we have this thing. Maybe I could do whatever. Let's just kind of simulate this, right? Let's say first we pick the first row, right? I mean, it doesn't even have to be optimal. It's just a possible thing. So this is 4 and this is 6. And then we choose the second row now. And then this is 1. This is 0. This is 9, right? And then let's say we choose the first one again. Well, this is clearly suboptimal, right? Because choosing the same index, the first column, I don't know if I said first, well, choosing the same index multiple times is clearly suboptimal, because you could just not choose this one in that case, right? This doesn't even matter. This could be a billion for all you know, and it doesn't matter because you chose it here, right? And that's the only thing that matters. So this is so the observation from this is that you will never need to pick the same index once, or more than once, sorry, right? So that was one of the things that I did realize. Yeah. And then the second thing is, the second thing is because of that, there's a pigeonhole thing, right? Meaning that the max number of do they call it turns or whatever? Operations that you can do is n, right? Basically, every column you do one operation. After n, it's -1, because that means that it can never get better, right? Yeah. And so from here, I actually did thought about this idea during the contest, but I just couldn't really put everything together in a good way. like I had individual pieces of the solution, but I just couldn't put it together at the end, right? And you kind of see me like kind of mentioning during the really long stream if you kind of want to watch it. But yeah, but given these two things, then now what I was thinking about, or knowing the solution anyway, what you want to do is kind of have this idea of, well, and for me it's not definitive, which is why I didn't like go laser focused on this idea and kind of explore it deeper. But you're looking at this hard problem is a very hard problem. I'm going to assume certain things that you already know, because if you don't, then you should just go back and I don't want to do a video on every component, right? But what I wanted to say with that is that basically you have just this dynamic programming thing where it's a DP that you've done many times, which is that for every index you either tick or you don't tick, right? And so that part, like, and you could structure it like in many ways. Like maybe you could do something like Go. I'm just going to call it Go for now, or DP maybe, fine. Like of index, is equal to something like max or min or whatever it is. I'm just writing the general thing of, DP of index plus 1, and then plus some cost of taking it, and then you know the structure, right? Something like this. And of course here we also have a turn component, and as we said they only end I keep on calling it turns because that's why I thought about it. Like every turn you do something kind of thing. But so that means that for every turn, you either take this turn or you don't take it, and you go to the next turn, right? So those are kind of like, this is a very I don't want to explain. I'm just showing this part in that I don't want to explain it, because this is a very common thing, right? But of course you can't just do it like, if you try to plug it in this way with a generic input, it's not going to work. So, and this is the part that requires quite a bit of just like exploring deeply and then figuring out what that means, right? So it turns out the magic thing is that, and let's kind of rewrite these a little bit in that, because I don't know why they're two different. So you have A is equal to 1 1, 2 2, 3 3, right? Something like this, right? Like, nums 1, they match with nums 2 anyway, right? And the X doesn't do anything in the sense that that's just like the if statement. So it's a very, it's not a function of X, right? So yeah. And then now let's expand on this, right? Instead of taking it on turn, on this turn, right? And there's some math involved with this with respect to kind of thinking about, the way that I thought about it is with simulation. During my portion of it, I kind of solved it of, okay, what if you look at it backwards, right? And there are a couple of ways you can look at it. They're all equivalent. These are just very mathy things. Like I said, you kind of start with this thing and then you go, okay, what if I take this and then, and go forth and all this stuff, and then kind of fill out the matrix that way with that simulation, right? So and if you kind of write out the form of the simulation, and I'm going to write this like very basic so far, is that if you kind of I'm not going to do the visualization here because otherwise I'm not gonna lie, I'm recording this. It's 5:30 a.m. in New York. I need sleep, so my apologies. But definitely just do it yourself. But if you kind of write out algebraically the formula, you have some combination of like some permutation of I'm just gonna so A11 plus some turn number times A of 1 2, which is the nums 2, right? Because this is basically actually let's say we end on turn x, right? So here the final sum is going to be this minus taking this on turn 0 or turn 1 maybe plus 822 so this is the first term, so plus this x minus t minus 1 or t minus 1, so it ends up being this. It's a little bit awkward for sure. This is actually 2 1 and 2 2 plus dot, right? So you kind of think about how I don't want to prove this. You know how it gets here, hopefully, and it makes sense, right? So this is kind of the jump in logic that, to be honest, I don't know how to go from now to the next step in terms of like me trying to solve it as a problem solver. As a problem explainer, I can explain to you why it works, but I still kind of, I don't have sufficient skill level for now, hopefully only for now, to kind of be like, okay, because of XYZ, all I have to do is do this. I'm not quite there yet, but so what happens is that if you kind of look at these terms, what you want to do is sort by the nums 2 terms. Why do you want to do that? Well, wait, actually, let me step back by a second. So there are a couple of equivalent ways of looking at it, right? There's this way of looking at it. Another way of looking at it is the inverse of it, right? Meaning that you have, let's just say you have total A1, like I'm just going to write A1t for the total sum of all these, the first component, plus x times A2, which is the sum of these components, because for every turn, you have the sum of that minus A11 plus t times A12 minus A12 or A21 plus t minus 1. So basically now we're just saying, this is the equivalent formula. These are the sum of the things. This is basically everything all together. If you kind of have a simulation matrix, it's the sum of all those things, except for you zero some things out, and then these are the things that you take when that happens, right? Like these are the numbers that you take away from the matrix. So it's the equivalent kind of sum, right? Because you're still trying to maximize this sum, just like you try to maximize the sum, but now it's just a little bit easier to say that we are, because this is constant. So to maximize this, to minimize this, you maximize these component. I don't know if it's easier for you, but for me, it made it more straightforward, the formula, which I don't know. Like I said, that's maybe a personal preference, and you'll see why. And I'm going to explain it in the way that I understand best, because I'm still shaky as is. So I want you to kind of understand this jump, hopefully, right? So now let's just, this is the same. So we're trying to maximize this part, right? And then it turns out the magic glue, as I said, is we want to sort all these terms by the nums 2. How do you come up with it? Like I said, I'm not quite sure. Hopefully, maybe the next time we do this video, we have a similar problem. Hopefully, I can kind of see where my head is at, and then kind of teach it as best I can. Right now, I'm not quite there yet. I still want you to understand the solution, But the idea is that, okay, now you're trying to maximize these things, right? And now here, as we said, now if we sort things such that we sort by nums2 from decreasing order, right? So another way of saying this is that 1, 2 is greater than 8, 2, 2. So the reason why this is helpful is because now you can fully exploit using this. What do I mean? Because it's not clear otherwise, because if you're not this thing assumes that if we're not taking it this turn. Let me write it out. The assumption is that if we do not take it this turn, we're never taking this index, right? I missed this assumption, but I just want to add that clear, right? But it's not always clear, like, if you don't have this structure, if you don't take it on turn 3, maybe you take it on turn 4. Why wouldn't you, right? But now, I'm going to prove to you why, after you have this structure, now you can make this assumption, right? And the idea is that, okay, like we said, we're trying to maximize this thing. We have A1 is equal to A2. Let's assume that maybe we want to try, and this is actually, you want to cheat, or spoiler alert, I'm using the exchange argument, right? Oops. And the idea is that, okay, let's say we want to exchange the order of these two because, let's say we have to use both for whatever reason, and we go, okay, let's say instead of this is on turn T, we want this to be on turn T instead, right? So then now your new formula maybe will look something like this, right? And then we don't care. It's not that we don't care about it. It's just that it generalizes, and for now we don't have to look about this, right? Well, now what happens, right? Well, in order to compare these two, we can just do a subtraction. That's how you do. So let's subtract this from this, right? And again, everything else cancels out, so I'm not, the dot cancels out is my point, right? Yeah, yeah, and you may probably already be ahead of me, me and my ASCII art. The A11 cancels out, a lot of things cancels out. So you have this thing minus this thing, so you have A12. Here you have minus A22, right? And so now we have to figure out whether this term is positive or negative. And of course, we know that, given that this is the case, then this is going to be positive, right? And what does this mean when this is positive? That means that this will always be bigger than this term. And because of that, now it allows you to say that if this A1 term, A11 and A12, if this term is in the, if there exists this item, I don't know if it's this, in the optimal answer, it has to be T, right? That's basically what we're saying, because in any other case, we can just, convert it. Or the other case is such that we don't use this answer, right? And now, because of this, now it allows us to give us a structure that here, if we don't use it, we could just forget about it forever. Okay? Hopefully this makes sense. We're gonna go over the code next, but this is the proof that I came up with by myself. I mean, don't want to take that much credit. Like, I cheated in the sense that, like, I looked at some solutions and then I was trying to understand it from first principles, and not like just look up an explanation. So that's just something that I do as well. Maybe you can do it with if you have enough experience and practice. What I don't like to do is, I mean, sometimes I do it the other way, because like for self-improvement, for this problem, I know that what I struggled with was the algo part. So I want to look at the code and see if I could rederive the algo from scratch. There are certain problems where like I know what the algo is, but my implementation is really bad or some weird thing. So I'm like, okay, let me look at the solution. Oh, sorry, let me look at the explanation just to see if I missed an observation that would make the implementation easier, and then do the implementation from like without looking at code to see if I can get that correct, right? But yeah, so this is basic idea. And yeah, and I actually did it both in two ways: the top down and the bottoms up, because the top down is gives memory limit exceeded in Python, unfortunately. But yeah, so let's go over it. So first of all, we bundle the stuff together as we said, and then we sort it by nums2 as the thing that we said. And here we calculate the totals. Let me actually move this closer to the thing. Let's say, and this is basically what we were saying, right? This is the total, and we subtract this magical thing. What is this magical thing? dp of ij, though I guess I have I here, so it's very confusing. Let's just do xy. Xy is the maximal score taking of the suffix input starting at index x at turn y, right? Yeah. So this is saying, so what this loop is doing is go, okay, can we do it with 0 turns? So then now at 0 turns, this would be the total score minus this thing, which is the maximal score of the suffix input starting at index 0, because that's how you do the suffix, which is the entire input at turn 0. And then you do it for turn 1 and turn 2 and so forth, right? So let's say you have a magic function that lets you kind of remove optimally. That's basically how this comes about, right? This is the total. You remove the optimal things. And then now, if this score is less than or equal to x, we can return I. That's pretty much it for this part. And then now this part, as we said, is the way, in theory, easy. Like I said, by itself, this is probably not a difficult part. But you know, it's about putting all these things together. This is the top down. I'm going to explain the top down, and then we can look at the bottoms up. Like we said, this times out, but you can also just write this as go 0 0 or 0 I, sorry, right? And this is the base case is we ran out of numbers, so that means that we're not taking any more numbers, so we return 0. If turn is equal to 0, we ran out of turn, so we're not taking any more numbers, return 0. Otherwise, and this is, you know, what we said, right? This is, we take this number and we don't take this number. If we take this number at the current turn, then we skip to the next number. We used up one of these turns, and then this is the cost, right? This is basically given this turn, we have this number because that's how many times accumulated, and this is the starting number. This is a formula that I'm not going to prove. I don't know that we talked about it a bit. If you want to understand this problem, you know, we've talked about it enough, I think, right? And then the don't take this number is pretty straightforward. And that's pretty much it. We're going to look at the bottoms up. I mean, this bottoms up is basically literally, you know, same idea of here. It's just that I just kind of wrote it, you know, this way with bottoms up for more space efficiency in an array, and without the stack memory allocations. So yeah, what's the complexity here, right? There's an n log n sorting, but obviously it gets dominated by this n squared term. So yeah, So this is n square time, n square space, the way that I wrote it. Let me just actually, hope you've seen this enough, so I'm going to delete this so you could see all the code in one page. But of course, now that you do it bottoms up, you can actually notice that all of the dp sub I depends on dp of I plus 1. So you could actually do the space optimization trick to reduce this to n square time and O of n space. Wow, this explanation itself is 25 minutes. So hopefully this is good for you. I really did enjoy this problem. I really appreciate learning about this, but it's really hard, right? So I don't know. So I consider it very hard for me. Maybe with some practice, maybe with these mathematical properties in my head, I could come up with it. But a lot of smart people didn't get it. So yeah, that's all I have for this one. Let me know what you think, and you could watch me struggle for an hour and a half before looking through solutions. Next. Okay, I wasn't sure about that one. All right. In terms of just like edge cases and stuff like this. All right, minimum time to make array sum at most x. Every second, y use num sub I, num sub 2 sub I. Okay. After this is done, you can do a for operation. Minimum times you get sum of it is less than or equal to x. Or -1 is not possible. How many people have gotten it so far? Wow, no one has gotten it yet. I'm assuming greedy doesn't work. 10 to the... I didn't even look at the constraints. 10 to the third. What is it, 1,000? Why don't you say 1,000? Okay, whatever, it's fine. What does it mean? Can I do DP? What is X again? Oh, that's the number that I have to less than or equal to. What does making a number 0 mean? So okay, so we call this every time we add the sum of nums 2 except for one thing that we also make 0. Ten to the 6. Oh, that's the number that's smaller. That's fine. It's not commutative, it's not distributive. The timing matters. Well, we're going to make at most. Is that true? I guess not actually. I was going to say that we can make at most n moves, but maybe you want to do the same place more than once. For example, if one of the numbers really big on nums 2 or something, like disproportionately, then you would do like every other step, just to kind of. No, is that true? No, because that means that if that's the case, you would reduce it to doing that big step last instead of doing it multiple times, right? So that means that by that definition, you would do each location or each index at most once. And if that's the case, what does that mean when that's the case? Looks like Larry's not sleeping early tonight. The minimum, so we have to minimize as well. I think I get the iterative process if I'm able to kind of build more from it. Basically, the idea is building backwards, maybe. And then if we could build backwards, then we can do a binary search, maybe. 10 to the third is 1,000. If we iterate 10 to the third, no, I mean that's just 1,000 times binary search, maybe on a step. That should be fast enough if that's right. I don't know if it's right though. And we greedily choose okay, so if we look at it backwards, what does it mean? Actually, we don't need to even binary search maybe then, if we're looking at backwards. Because we can just a priority doing it. Okay, let's say we're applying the operations backward. I think that's the way to think about it in time. So then now maybe you can do greedy. So then we choose one number to be 0. We choose the second number to be num sub 1 plus num sub 2. And then the third number will be num sub 1 plus no. So, okay, we start at 0 for the first number. The second number, it'll be num sub 2. The third number will be num sub 1, oh sorry, num sub 2 times 2. And that means that we should be able to use sorting. Because basically we assume that the rest is not being used, and then we incrementally build on that. How many people are there now? Still no one. I don't know if that's right then. I feel like people are very smart. How? I don't remember how to do this anymore. We'll sort by num sub 2. I guess I could just zip them and then sort that as well. We want to actually maximize this and maybe maximize this as well. All right. And now, so the total score, let's say we have 0 iterations. 0 iterations is just, okay, so the current is going to be sum of nums of 1, right? And then now for each choice, maybe that's why I have to do n square, because I'm a little bit sloppy on the get min. Maybe, I don't know. Okay, so okay, so now what? So we choose one of these and make it 0. Now we choose one of these. We okay, let's focus one step at a time first. So we first choose of these, and we make them 0. And by that logic, we want the max item, right? So okay. Now I guess we can just choose. Do I need the index? Yeah, I need the index. That's why I do it this way. Okay, fine. Okay, fine. It's a little bit awkward. If not used by and b, or we want to try the max. Okay, and then at the end we set this equal to t times nums2 of this, and then use the biggest index is equal to true. Okay, so we set, so current, we want to okay, fine. If current is less than or greater, we turn 0, I think. Otherwise, okay. So we add this, which is fine, but we have to subtract a bunch of stuff. So we made it, so okay, so we subtracted by num sub 1 of biggest index. We replace it by string, okay, that's fine. And then the next step, there's a bunch of other stuff. Yeah. Okay, so that's step 0, right? Okay, so that's step 0, and then now step 1, what am I doing? Step 1, I'm still looking at the biggest index, that's fine, and then I replace it with t times, okay, that's also fine. Wait, is that true? No, you want the biggest delta, so that's not quite right. You want to read the biggest index such that this minus num sub 1 of, oops, something like that. Okay, and then now for the rest of it, I might have to even do other stuff. So that means that for the stuff that's not used, we actually add an extra thing. So the nums2 total, we actually subtracted by am I doing this right? This is so much to juggle in my head. Nums2 total is the sum, and what are nums2? This makes this part a little bit off if I just subtract it by, or if I added. Basically added, but then something is a little bit off the T part. Because in this case, then you don't just subtract this. What do you subtract? Oh, is this? I guess in that case, I don't even need. One, two. I just need this then. This is very awkward. I don't know if it's true. Take a look real quick. What it looks like. Nums is not defined where. Three and -1. I'm still not confident about the solution though. In fact, there's only 6 people got it. All right, let's YOLO this. Now, I should at least test something that I know. All right, let's I don't know. Let's run this real quick. Okay, that's too small. Really? That's still too small. Yeah, because it's less than 10. Is that true? After one iteration, you have 2, 4. Yeah, I guess that's true. I'm just going to YOLO submit and get a wrong answer and then figure out that way. So I don't know how to come up with examples this one in less than 5 minutes or whatever. Okay, so this is 16. I'm returning -1. It should be 4. Okay. Of course, don't do this in code force or whatever. What am I doing in greedy? I'm minimizing. I'm not doing this. This part is wrong. I think what I want to do is this. Oh. So the biggest number is. Can I do it backwards? Am I doing that wrong? Because okay, let's say we do it in 1 step backwards. And you're done. Does that mean that your second step will be optimal? Because now what you want to do is actually minimize. What you want to do is minimize. So what is the cost here? Maybe I need a heap in some way, but what I want to do is minimize something. Okay, so that means that if that was doing at first, then that would be plus num sub 1, I see. So then now you have to choose which one to. Yeah, maybe my greedy is a little bit off in how I structured it. Expected 4, what order? So the way that I would order it is the 10, 9, 4, 4, which is clearly wrong, because the 4 and the 4 has the 4 multipliers. Maybe I do need the binary search. N times n log n is a little bit slow though. 10 mil. The binary search would solve this, I think. But it is genuinely maybe a little bit too slow in Python. 10 million, yeah. Also, yeah, if I did it this way, I could just use indexes, which I kind of threw away. Can I do it without binary search? Let's see if this is fast enough, I guess. I don't really have any ideas about it. If this is good, what happens then? We try a smaller number. So, okay, so maybe I should switch language as well, but that's besides the point. Alright, let me just simplify it. Okay, and then now now we can change this formula to but now we add okay, that means that now, what do we do? Well, we set it to 0, so then we subtract this. What am I doing? No, I don't even need this anymore, actually. That means that we chose I, and I is going to be so this is the maximum. Maybe I'm doing this wrong. This is the maximum thing. If we don't choose it for this stage, if we do choose it, then it's just this. Oh, then that means that I have to subtract this to do it. Oh, this is not a thing anymore. Well, that's unfortunate. Because mid is good. You want to do 2 steps? Is that true? 0, 2. Oh, I have to add everything else, that's why. No, I don't need to do this. It's 3, -1. I think this is -1, and this is, I still get it wrong with 4. Why? 4 is 2 is too small, so then now tries 4. 4 is 18, is the smallest. It should be 16, is it? Why? So by greedy, maybe my algo is just really wrong, to be honest. I don't know that my algo is even right, clearly. So you do 3, okay, and then 0. So then now this is 4, 2. So then now this is 2, so that's 6. And then 1. So now that's just 12, right? 6. Yeah, so that's 18. I guess that's wrong. That's definitely wrong. Well, I mean, the calculations is right. The answer is wrong. Okay. Huh. What is the right way to do it then? What is the right order? Ten to the 9, or 10 times, I mean 19 if we don't do it at step 0. Man, I don't have any idea on this one. A couple of people responded, but not that many people still. What is the optimal solution here? Let's say we're looking backwards. You have 9 as the so we want to let's say we take it. This is like so far not right. Okay. Let's look at the pen paper thing. So okay. 19 to 0, right? And then 4, and then 8, and then 2. Did I mess this up? Oh no, this is 3, but that's 15, so that's right. So why am I, so I'm doing the, so I need to do the 4, the 2 sets of 4s if I want to do it right. And the replacement is it's because okay, so let's say I replace this. I might form this wrong. Say I replace this now. My benefit is actually at the current step, your cost is 12. If we don't replace it, this cost is 11. So for the 4 we have 3, but then 0 and 2. On the second step, that's 11, and that's 12. We replace it, so the benefit here is that it goes from 12 to, if we do replace it, the benefit is the target minus t so okay, so you have, okay, so what is it? So the before is if you don't replace it at the stage or total stage, I don't even know. If you don't replace it, it is nums1 of I plus target times nums2 of I, and then replace it with t times num sub I. I guess that's what I wrote, except that now I have an extra one for some reason. Maybe I kind of messed that up, confused myself. Okay, well, it fixes it, but I don't know that it's right. It's just that it fixed one thing. Alright, let's give it a YOLO. Oh man, oh well. I mean, I don't know that I have real expectations for this one. So I think it's 4, but the optimal was actually 2. Why? Tell me why. So for my algo, it thinks 3 is not good enough, so that's the reason. So I see. So you can't binary search because, at least not the way that I'm doing it, because 3 is no good, but 2 is good. 2, which 2? Say this one and maybe this one. So then now you have 7. Instead, what did I do? Well, let's take a look at. Two is 59. That's just outrageous. Which 2 indexes are you doing? 2 and 4. 1, 2, 1. And then everything. So this is just 3. That math wrong. So now this is 9. That's 20. 25, 40, 32. Did I mess something up? Oh, maybe this part. How did I have 59? target. Is that true? It should be. After 2 steps, this is target. Yeah, no, this is right. How am I getting such a big number? 59. Do I really have to like print everything? What? Oh my, how does this pass anything? What a typo. That's what I get for mixing I and index in words. Deserved it. I mean, I don't know if this is right, but it is. It is at least something. Maybe it times out. If it times out, then maybe I will switch to C++. Also, I left this in by accident. Okay, wrong answers. Maybe, I don't know if it's better, but timeout would have been very painful. Because, oh no, timeout would have been great, because then I would just straight up do it. Expected 8. Can't believe I have such silly mistakes there. I guess I can believe it. 8 is 41, which is 40. So I guess we probably have a wrong answer somewhere still. And the greedy is just not good enough in this case. I think we finally got it, the code to be what I would want it to be. Yeah. But maybe it's wrong. Guess 41. That doesn't make sense. So that's a little bit sad. Oh, because it. Okay, yeah, I expect that. Okay, that's good. I mean, it means that I have no idea how to do it, but it's good in the context that I don't think my code is bugged. It's just wrong. I'm trying to do some variation of the exchange argument. Yep, Alex hasn't gotten it. And Alex, you know, I respect a lot, obviously. But this is not right. If it's not greedy, then what is it? I mean, this thing we could have sorted by it, so this is actually kind of an awkward way of doing it. Maybe. Oh, sorry. How much time do I have left on this one? 36 minutes. I have no idea, so it may be that I just don't know. Maybe that this is just sorting and I'm kind of, because the way that I've structured it, it could be sorting, so what am I doing? That's the replacement. My one is this is a different T. Oh no, it's not, but it's it was just a YOLO, to be frank. Because I don't think this quite makes sense. I think there's two stages. you group them by the numbers that are here, there, and then you sort it. Or like there are two groups. You partition them, and then you do a. That feels hard. I don't know if that's the way I would do it necessarily. And get a repeated min on it. I think all the answers here are what the. Oh, I deleted stuff. Whoops. And then. I think I had the submission. No, not that one though. All right. How am I so bad? That didn't fix it. Huh. Yeah, I don't think I have any idea on this one. I mean, I'm using like a lot of variations on greedy, and it hasn't really been working on binary search. But the optimal solution would have to The minimal. Okay, so we don't need all this. What is the minimal we're doing? The minimal would be just t times length of I, maybe. Yeah, didn't fix it. It's still 7. Trying like random stuff to see if it works. I don't think I have any idea on this one, to be frank. What are you doing? But yeah, I don't know that I know how to do this one. It seems like only 47 people got it. How much time? 23 minutes. Can I grind 23 minutes? Do I even have it? Like, I want to start over. Okay, so maybe it's not binary search or greedy. Is there a DP? I don't know. What would the DP even look like? No, because the ordering matters. No, the ordering matters. I don't know how that I can separate it. Is there a pseudo DP? Does it matter that all the numbers are just, the domain of the numbers are small? So each number is 1,000. There's 1,000, and it takes 1,000 times. So it could be 1,000,000 times, or 1,000,000 plus 1,000, or something like this. And this is just Larry banging his head on the wall for this one. Does the X matter? I mean, does it matter in the solution? So we're gonna use it even almost once. So that's not the right grade, but Reorder on the order doesn't make sense. Try to cover functions. Can we DP? I mean, the assumption is that we don't use the same thing once, but maybe we don't need to use that assumption if it's just built in that if you do, you're just silly. No, because then it just becomes an iterative thing if you do it that way, and if the thing was to bound by n square or 1000 square. I have about 20 minutes left. I don't know that I'm gonna grind it out, even on a good day, let alone on today. I'm grinding hard for it too, but way. I mean, the simulation makes sense. It's just that I can't find it. I mean, greedy is not the right way to do it, even in a binary search situation. I thought this would be right, but I guess not, so. Let's see. How would this be wrong? I see. I don't think. Yeah, I don't think I could partition it this way. Doesn't make sense because you're making incremental progress. So it is not always. Maybe I just need to be smarter in the simulation. But I feel like if it's just like a smarter simulation by now, more people would have gotten it. So I don't, like in a meta kind of way, I don't think that that's the way to do it. Does X matter? Or is it just a termination condition? Man, I'm going in circles, so I don't think I'm getting this, but... How much time do I have? 15 minutes. Yeah, I'm still stuck on this idea. I can't think of any new idea. If it's not DP, if it's not greedy. It's still an exchange argument. Like a bubble sort? No, you can't do... I'll just keep on... Binary search of a bubble sort? Would that even make sense? I'm out of ideas, so why not? But then you can't... Can there be like a A is greater than B is greater than C is greater than A situation? That's the only... I mean, why else would you do bubble sort? Huh. Oh, man, if I have energy, I would try to at least stay up for this, but... Yeah, and I think I'm going to just take a break. I don't think I'm going to make any progress in the last 12 minutes. So yeah, BRB. Thanks for joining us. Right now I'm just kind of rereading Q4 of the bi-weekly. We're trying to learn. Well, a lot of people end up solving it, about maybe 82. That's not a lot actually. So I'm just trying to learn afterwards. I don't know how to do it. I can figure it out. So it's not binary search, but what does this even mean? Let's see if there's a easier. So there is a DP. Yeah, so there's some DP here. I was trying very hard to kind of think of it, but I just couldn't think about it. Maybe I was just very wrong. Let me try to see if I could figure out the recurrence without, or just understanding this recurrence, I suppose. I mean, I had done a lot of these things, but there's an awkward way of phrasing it. But definitely did not get this one. Yeah. So we sort by. Don't know if I could read that one. Oh, I mean, I had something like this, but not the DP part. I guess there is some DP, but I just don't understand it. Can I understand the DP part? All right, let's look at the other, the binary search one first. Let's see if I can understand it. So okay, so let's just say, can we? Yeah, this is regular binary search. Is there an answer with mid? So I was trying to do something like this, but in a greedy way, which didn't work out at all. So I missed the DP part. So I is the number of turns. Where is it? No. So the new array. So it goes up to mid, right? So that means that the hidden dimension is mid, that it gets space optimized away, and these are just the indexes. What is it saying? It is saying that DP of I thought I was trying to. I did think about something like this, but I couldn't really come up with it. But this is saying that the last time it is updated, because yeah, sorted by B. That's why the index is different. I had something like this, but I couldn't figure out the DP. So basically, it's saying J minus 1. Why is the I loop on the outside? That's the confusing part for me. DP sub J is the DP of turn. So DP sub J I would have thought that is the other way, to be honest. I I mean, I had this, but I was trying to do it greedy. But, huh. I need a two-dimensional version. Maybe that'll be easier to remember or to understand. Uh, Definitely not quite seeing it still. Maybe the two-dimensional version is too slow. That's why everyone has a one-dimensional version. But oh no, this is a two-dimensional version. I don't get why it's IJ and not JI in this case. Hmm. A very funky way of writing this, but fine. Oh, so this is the total minus trying to maximize the oh, so you're trying to maximize the number removed. And if you remove at a certain point, what is DPIMJ? It is the maximum score remove of item I don't know how the states don't repeat. I think that's the part that I was confused about in general. It's not just okay, so this is num sub 1 of I. So J of that means that's how much it was. I see, because now you're maximizing all the accumulation that you remove. So that's why you're counting upwards as time progresses. So then now you're maximizing, okay, the first level. So basically you're saying you remove at this current time or you don't remove at this current time. I see. Let me see if I can figure that out. Huh. I wrote so much random crap. Okay. But there is the sorting aspect. Why does the sorting matter? I think that's the part that I missed. sorting by nums2. Why does the sorting matter, huh? Oh yeah, so okay, let's go. So we have an index, and then we have a turn. Say, is it turn or step or whatever they call it? Operations. That's fine. And then basically, if index is equal to n, we return 0 or something. Yeah, because you're not removing anything. Otherwise, we basically take or don't take is what they're saying. So if you take, is that right? That feels a little wrong. So if you take it at this time, so you can't take it again. Otherwise, you might take it at a later time. I see why there needs to be sorting, but I don't know that I understand it. Okay, wait. Because if you're trying to sort by nums2, then I mean I get it, but I don't get the proof. This is okay. So we take it and now the number that you take at that time as accumulated nums of 1 of index times turn. Oh, sorry, plus turn nums2 of index, right? Something like that, maybe. And then don't take. This is a little bit awkward. But this predicates on the sort, otherwise it doesn't make sense. And I don't know that I understand the sorting right now. So oh wait, no. And then now we do thing. What am I doing? So turn 0 would be so that's the total. And then we subtract it from goal. Oh, in this case, that technically I have to count down. So then I can do return. right? Something like this. Oh, whoops. This isn't quite right, I think, but return, so maybe this is off by 1, no, off by 1. Understanding needs a little bit more. So the only way that we would change is because it assumes that in future turn this number gets bigger, so in a way we want to optimize for that, I guess. Okay, I mean, I think I'm making sense of it. Don't know if I can come up with it, and it's still a little bit wrong, but unless I did it backwards by accident, maybe. Okay, so if this is 0, then it's 0, 0, then we just return 0, okay, fine. If this is 1, then you have just this, then 0, 1. Seems right. Why am I gonna wrong? Is it supposed to be less than or equal to x, right? Okay. Oops. Man, I'm mixing languages. So removing 0, we have 6, okay. Removing 1, let's say we remove this one. Is it still 6? Oh, I see. This needs to be inclusive. Okay, I was just being dumb. Is this right now, though? Let's just YOLO because I'm... But... Maybe it times out just because I was lazy on it. That's why people rewrote it or something like this, yeah. You know this is n square. That's just Leetcode being silly, I think. And having 1,206, but that means that we're right, but okay. I mean, I was playing around with this idea, but I think I didn't know that I want to... This way of writing is a little bit easier, but I didn't know that I had to sort it by this. I think there's some, like, property that I have to kind of think about it a little bit offline to figure it out a little bit. But for most purposes, this is right. It's just that, you know, we have to... come on, fam. We have to rewrite this or something, like, to be bottoms up or whatever. That's why people did the optimization. And here we can and rewrite this, right? So we have dp is equal to, let's just say, oh no, in this case we have 0 times the inner was its turn, so turn is going to be n for n, and this is actually n plus 1, right? And then for I in range of n, for j in range of n plus 1, it's just take or not take. So yeah, dp of ij is equal to max of dpi plus 1, j minus 1. Oh, no. And we can probably rewrite this a little bit, but because now the dependency is a little bit off, so we should and maybe we can just expand this to this, right? Right? And now it's just dp of I don't even have the answer for this one, but they didn't give it to us. Our answers are wrong anyway. But because I didn't, I'm missing the base case of j is equal to 0. Oh, and also yeah. Which one is this? Why? Oh, whoops. Let's see if this works a little bit faster. Definitely more memory efficient. Yeah. So I think this is just like, very straightforward take, no take. I mean, and people write it in a number of different ways. But I have to think about how to combine this with the sorting. Basically, the idea is that nums2, which is this portion, the idea is that if you don't do it on, let's say you start with a late turn, if you don't do it on this turn, you're not going to do it on a later turn. Because of the exchange argument in a way. Because that's really hard to come up with. Because basically the idea is that if you either don't solve it, or if you solve it, you do it on the highest turn possible. Because in a greedy kind of way, because we sorted by maximum nums2, in a greedy kind of way, if you don't take it now, it never makes sense to take it later. Because if it did, this term would be as big as it is ever. It's just about the question of this term. And so if you don't take it because of this term, this one will just get a little bit smaller. And because by definition, in the future, this term will be smaller. Yeah. I kind of see it, but I have to kind of, like, is it a proof? No. So yeah. Um, Basically, there. I mean, it's kind of it is the exchange argument, and you can kind of prove it by just being with an exhaustive proof. Let's say we have um, a11, a12, and a21 maybe, and then a12 and a22, right? So the idea is that now you have a thing where you have a11 plus t times a21 with a comparison of a12 plus t minus 1 times a22, right? And given that a21 is greater than a22, this term will always be bigger than this term. Or, well, this term will always be bigger than this term, but this term will be always. So as a result, this term will always be bigger than this term. So then the question is about, so if we don't use this one, but we use this one, there's never a case such that it is more optimal to do this it's never optimal to do this because by the exchange argument you can just by the exchange argument, because we know that a21 is greater than a22, we can just add we can add a21 on both sides and then subtract a22 on both sides, and then you get and then basically now you have a11 plus, well, you just have this really, right, on both sides. And but because you know that this is true, now if we're trying to maximize this comparison aside, okay, another way to write this exchange argument is not using this question mark comparison, but a plus, right? Because this is we're trying to maximize this function, and the exchange argument is that now, let's say we have this, and we know that a21 is greater than a22. That means that this formula, you could say this in a number of ways, but the idea is that this formula subtract this formula is equal to subtract is equal to a21 minus a22, I think. And because this is a positive number by definition, because as we said h11 is equal to a22, then this answer will always be better than this answer. So that's why it's either you don't take it, but if you are taking this, if this is the case, this will always be better. This is a good thing. I'm convinced, or like, it's good enough of a proof, but I'm trying to think, okay, now you have a proof, and now you understand the solution, but does it mean that, or like, how do you come up with it, right? And I don't know. I'm going to sleep on it, but that's all I have for this contest. Let me know what you think. I do love this problem, but it just involves putting together like 3 really difficult things. And of course, if you look at other people's solution, it's basically the same, but it's going to be an explanation part. This is the me understanding part post contest. Do I understand it? Yes. Can I come up with it? I don't know. Probably not, to be frank. Even now that I learned it a little bit, I would have to do. If I have to guess, I would have to do this like 3 or 5 times like similar technique before I really get it. But it is beautiful. I do appreciate this problem. I just don't know if I could come up with it, even unknowing. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.